So I really want to start talking about some lingo regarding differential equations. So a lot of times when we write down differential equations, we give them names specifically to say something about them without even beginning to examine them. So for example, let's first talk about some notations. So obviously, probably what a lot of people are used to is y prime to be the derivative of y. Another thing might be f prime of x. Some Newton people might do y dot, where the dot represents what derivative it is. So a lot of times what we do is we write differential equations. So if we write something like y prime plus y equals 0, we would call this a first order linear homogeneous um, ODE. So what do these words mean? So the first part is we call it first order because of this derivative. If this was, for example, y double prime, then we would call it second order. So if it's y to the nth derivative, we call it nth order. So really this first part only says what's the highest derivative in the differential equation. So now let's talk about linear. So what does linear say? So linear says that all of the coefficients on these guys are basically not functions of y or its derivatives. So what does that mean? So in the case here, basically you have 1 times y prime plus 1 times y equals 0. So the coefficients here are both 1s, which are not functions of y or its derivatives. So a way to say that this would be nonlinear is if I said that something like y prime plus y squared equals 0. Well, that's nonlinear because if I look at this, that's y prime plus y times y equals 0. So here, even though I have a coefficient of 1, here I have a coefficient of y, which makes it nonlinear. So another example of this guy that would be linear is if I did y prime plus xy equals 0, this would be linear because the coefficient here isn't dependent on y or its derivatives. It's only dependent on the independent variable x, which is okay. And even to compare with this thing, even if x was nonlinear, let's say y prime plus x squared y equals 0. This is still linear because even though x squared is nonlinear, it's not, the coefficient itself is not dependent on y or its derivatives. So that makes the ODE itself linear. So what does this homogeneous ODE mean? So I'll go to the next page for this. So if I look at y prime plus y equals 0, as we wrote there, the homogeneous part basically says that this is 0. We call this a source term usually. So if we wrote something like y prime, y prime plus y equals x squared, well, this would be we would call this a non-homogeneous equation because, right, this thing is a source. It's not 0. So homogeneous equations are equal to 0. Non-homogeneous equations are equal to x squared as a source term. So basically, what this means is, if I can basically write, what's the best way to say this? So if I can write the ODE such that I can't get, so if I wrote something like this, then this is basically a non-homogeneous equation because, right, obviously this is just equal to x squared. So pretty much if you have, if you look at the equation, if you could basically write it like this, well, okay. So if you can write an ODE as a function of, we have all of our derivatives up to the first derivative, and we have x, and we can write that as being equal to a function, well, if we can basically write that as, if we can basically write that as not being a function of x, that is, we sort of say this, but we sort of take out of the account that, f of x cannot be, okay. So if f of x cannot equal 0, because obviously if f of x equals 0, it's homogeneous, but if f of x is something other than 0, then we would call it a source term, which basically indicates that it's a non-homogeneous equation. So basically, if we look at something, let's say y to the fourth plus y double prime plus y squared y prime plus x equals 0. So we would call this a fourth order. We would call this a fourth order because highest derivative is a fourth derivative. We call it a fourth order nonlinear. We call it nonlinear because even though this coefficient are both 1, there exists a coefficient where it's dependent on the solution itself. So that's why it's nonlinear. So it's a fourth order nonlinear, non-homogeneous ODE. And it's non-homogeneous because obviously we can rewrite this as y to the fourth plus y double prime plus y squared y prime equals negative x. So f of x does not equal 0. So that basically means that it's non-homogeneous. There's a source term. So that's just basically the basic mumbo jumbo and some of the buzzwords, at least in ordinary differential equations. So until next time.